The speakers for this session are Erik Schamper and Willem Zeeman from Fox IT. Erik is a security researcher at Fox IT and is one of the key authors of the enterprise investigation framework Dissect. Willem is Principal CIRT Consultant who is an expert in usage of tools such as Dissect. The session is titled Dissect, the Solution to Large-Scale Incident Response and Why the APTs Hate Us. Welcome to Erik and Willem.
Us? No? Okay, see? Oh.
Check. Checking. Fine. Right.
Okay. Ah, apparently it works now. Cool. So yeah, thanks for the introduction. I think a lot's already said. We're going to tell you about why we developed Dissect and why it helps us doing large-scale incident response. So, and without further ado, let's just jump right into it. Starting with this. So you wake up, it's almost 8 o'clock in the morning, and you receive a text message. You know you are on an incident response engagement, and yeah, this is of course the first thing you want to read then, right, when you just woke up. So the question is here from the customer, what was initial access and what happened? What did the attacker do? And to make it a little bit more challenging, the customer asks you to have all these systems reviewed by the end of the morning. Question to you. From a technical point of view, what would you do right now? You're in the lead, what would you do?
You already received all the data. How do you process all of this data in just a matter of hours and actually get some useful answers that you can give the client and help them resolve this incident?
Anybody?
I would ingest it into the same rules engine.
Sorry?
I would ingest it into the same product with the rules engine and things that I wanted.
Oh, so you are going to ingest all the data you received into a Zeeman engine, for example. Okay.
And then process it, I mean.
Okay, cool. Anyone else?
What sort of data we have?
Yeah, just all kind of images, all kind of source items actually.
Virtual machines, cape images, full disk images, everything.
Well, first of all, I wouldn't go right to the images because I would spend lots of time. Maybe I would go and look at some, for example, registries, autoruns, Sage would show adjustments, low-hanging fruits, but not do the direct image of all the machines.
Yeah, so what we are going to explain is of course about large-scale incident response, and we'll do a deep dive as well into it. But the Dissect framework enables you to leverage tools like target query. Target query is one of the main commands you will get available when you use the Dissect investigation and processing framework. So for example, here you see a query or just a command line. You can type target query -f and then the artifacts of your likings. And then, as you can see, just the systems folder with a wildcard. So that's where all the systems are, okay? And the -f, that's the one who gets to decide, who you can get to decide with what kind of plugin you will run against the data. So for example, you can use hostname, version, users, but also run keys, for example. But there's much more to that, of course.
Throwing me a hissy fit. Okay, next.
It's all part of the exercise. Here we go. It works on my machine. Okay, so there's a lot to it. And just jump right straight into a demo.
Yeah, let's just, don't do any text slides yet, just go straight into the action. So let's start off with reviewing some of our analysis data. We already kind of hinted towards it. It's a mix of various source types. We have some tar files, which are kind of these forensic packages that we'll get into it a little bit later. We have some VMX files, VMware hypervisor files, VMCX from Hyper-V, even some VMA files from Proxmox backups. Key 9 among you might notice is not quite 143 systems, but it'll do for this demo. All right, let's first look at the available commands to us, if it's going to work. Oh, okay.
Yeah,
Interesting.
it flips back sometimes.
So
Right.
let's try to get started again. Hopefully we've resolved all the technical issues. Let's see if this works. Thank you for your patience. Now the final test, if this actually goes to the next one. Let's see.
Yes.
Yes, all right. So finally, we can see all the tools available to you, or at least some of the tools available to you within the Dissect framework. We're only going to be taking a look at some of these within this demonstration. However, most of these are quite self-explanatory based on their names. And otherwise, you can, of course, just look it up yourself afterwards when you start play with Dissect. So let's just start off with a very simple query. We're going to request the hostname and version of all of the systems that we just saw in the previous screen. And if you remember, there was a mix of virtual machines, Proxmox backups, and forensic artifact containers. And it just starts running right away. We get some output pretty quickly. And from all of these systems, we get some basic CMDB information. So let's continue to something a little bit more exciting. Actually, we're skipping to already showing again some of the plugins available to you. And as you can see, it's not just simple information such as the hostname or the version. It's also some more actually actionable artifacts that you can do stuff with. So let's look at one of those, the run keys. As anyone knows, every advanced attacker achieves persistence through the run keys. And if we let it run again, we can see it very quickly starts exporting the run keys from all of these different source items. It's already done again from all of these systems in that folder. So now let's do the next most, that every forensic investigator, of course, does, which is grabbing for malware.exe. That's always how you catch the bad guys. We can see one run key over here. It's totally legit, and it's pointing to a malware file in the perflogs directory. Very briefly about what you're seeing right now. You're seeing a quite simple key value format. It's called flow record. We'll get into a little bit more detail about that later. But the most important thing here to note is that we get some information from the run key. We get some information from the user hive and the user that actually has this run key. This is a fairly human-readable form, but we can machine parse this way better later on. So let's continue. We now have a host name of an interesting system that has some malicious activity on there. Let's use the target info command to quickly get some quick information about this system. So since it's a tar file, it obviously doesn't have any disks or volumes or partitions or file systems, stuff like that. However, we do get some operating system level information, such as the install date, last activity, and information about the Windows version. So let's actually get to this piece of malware. We're going to use the target shell command for that, which drops us into a virtual shell on this piece of evidence. And right now, this might seem easy on a tar file, but this works just as easily on any of the source material that we saw in the previous, at the beginning of the demo. So we have some simple commands available to us. It acts just like any other shell. We can list directories, we can cut files, we can pipe it to commands on our host system. Seeing that it's actually a Windows executable file, we can directly hash files from this. And we can also very easily export files to our host file system. And in the end, run exiftool, because why not? Definitely found the APT now.
And that goes without saying, this was all without mounting a single image. So make the data fit you like Erik just told us. This was output, and we call that flow records. But you might prefer your own output. For example, JSON. So what you also get with the Dissect framework is access to a tool. It's called rdump. And rdump makes it possible to output to different formats. For example, JSON, but also CSV format. But that's not all. You can also stream it to your favorite data collection tool, like the Zeeman we just talked about in the first minute of the presso. So we use a lot of Splunk, but there are also analysts we know of who like to investigate and process using the Dissect framework, because you can process, you can put a lot into Dissect, it will process it, It will output what you want, but then you have to do something with it. For example, investigate. But this investigation can also be done in Splunk. So you can stream it to Splunk, and there you have all your dashboards and all your Splunk tooling available. It's not only Splunk, we also created a plugin for Elastic. So that's great for if you have big data sets. So it's important, it's no matter the format, no matter the amount, no borrowing steps like mounting stuff. You can just start investigate immediately on your data available. And the best of all, it's open source now. Since the end of last year, we've open sourced it, and we can all install it. You can all install it just by typing pip install dissect. Also check out the repo and maybe even contribute to it if you are going to use it in your daily investigation lives.
All right, so diving into a little bit more detail, what actually is Dissect? We just saw a little bit of a demonstration about what it can do, but you still might not really know what it really is. So very simple, it's a modular pure Python framework, and it consists of a lot of different libraries and some actual usable analyst tooling. In total, I'd say probably over 20 plus libraries for things like NTFS, XFS, VMFS, different for your management implementations, registry hive, stuff like that. However, if we would have just open sourced a whole bunch of new libraries, just another NTFS parser, another XFS parser, nobody would have really been happy, right? Because then you'd still have to write your own code to interact with these libraries, interact with your source material, doing all that manual work that we just said we didn't want to do anymore. So that's where Dissect Target comes in. It's kind of the meat of the framework, what really brings it all together. So Dissect Target is the part that really automates everything and allows you to really easily go from any of that source material to actionable artifacts into stuff like Splunk. It's all based on a decade of both incident response and development. This goes hand in hand. So really, solving the challenges that we solved during that decade of incident response. The cases that we did, they became larger and larger, more complex. The kind of adversaries that we were encountering in these engagements, they got more and more advanced. And we really needed, the tools to be able to tackle all of those investigations. And Dissect is what, was the combination of, or the result of all of that.
So yes, we actually created it because we wanted to solve these tough challenges. Our cases grew and we needed some flexibility. Actually we needed zero compromise on flexibility. So everything we were willing to create, we just could, and then put it back into the main Dissect framework. And if a next investigation or incident response case came in, we were easily able to do the same stuff again from a central piece of from our central workflow. Also, it helps us with the team distribution because we can easily now size the team. We can add extra people, and they all work with the same tooling. So with this central framework. Also, it's much easier in terms of skill sets and to mix that up because we all know from each other what we are exactly doing in this tool. So it also means that if we have a large bunch of data to investigate, that it doesn't really matter how deep we will go into one source item because Dissect can do that all. But as first, like with the example of the 143 systems, we get a bunch of data, and then we want to have some triads on this data, what's actually happening. So first points of infection maybe, stuff like that. And if you want to zoom in, that's also what Dissect can do for us. So there's also no actor beyond our reach. And why open source? Because of our slogan, maybe, mainly, because that's for a more secure society. So now everybody can benefit from this tooling. And it's not only for analysis, we also created Acquire, which is also part of the Dissect framework. And what's Acquire? It also has to do with all this investigation data. You have to collect that in the first step. I mean, a gig starts and you're asking the customer, okay, just deliver me all these full images. That's way too much. So that's why we created Acquire. And Acquire enables you to start it just on a system. It works on multiple operating systems, and it will create these small forensic packages. And in these packages, there's maybe we can tell as much as 80% as we normally could do for a full disk image. So this tremendously speeds up the time of the data collection, which is great, of course. Also, if the customer has a big data store available, for example, just a disk with a lot of VMs on it, which also to our data store which they cannot ship to us, they can also run acquire against all these images over there, and we'll create these packages, and then they can ship these smaller packages to us. Some numbers, so just know normally we deal with, maybe on your average ransomware case, for example, about 100 systems on average, and we can do that now leveraging Dissect with just one host analyst for a few days. Our biggest till date was around 250K source items, where a lot of different items in that. Think about virtual machines and specific requests for user profiles, which were in the tens of thousands, and thousands of servers, thousands of endpoints. And in the end, we were able to do that with only 2 host analysts. So yeah, we thought it was pretty cool, but it gives you some, of course it's a bit of a flex, but it gives you some sense of what it's able to do. That was the main point here.
Right, so let's go into more detail on that one point, zero compromise, and dive into some of the more nitty-gritty stuff of Dissect. So what happens sometimes is, we're doing an investigation, perhaps we found patient 0, and the client comes to us saying, hey, I have this backup of patient 0 from around the time of the compromise. All right, great, so we want to investigate that. However, this backup is in a format we haven't encountered yet, we've never seen it before. Now, the one thing we could do is, reverse engineer it, do manual analysis on it, run some separate tools on this stuff, files that we extract from it, maybe carve from it. But then, the client might come back and say, hey, great, you analyzed that one backup, we have 1,000 more. Maybe you can do that analysis on those as well. So what we tend to do is we write parsers, proper parsers for these backup formats, for these new file formats, and put it into Dissect so that we can immediately start using all of the existing tools, all of the existing parsers, all of the existing artifact parsers and automation pipelines that we've created over the years on this new data format. And when a client comes back with these 1,000 systems, we can say, yeah, sure, whatever, just ship them to us, and we can process them in a matter of minutes. It's not just, of course, the case for exotic backup formats. It's also for things that are new in the industry. So, for example, like CAPE collection packages, or Tanium forensic collection packages. These are also kind of the file formats that we can very easily plug into Dissect and have the rest of the code work automatically, the rest of the artifact parsing work automatically with this new format. Another fun one that we talk about a lot is kind of the flexibility of the framework. So what happens sometimes is ransomware gets deployed on a hypervisor. The virtual disks are partially encrypted, but in this case, this particular case at least, it was quite poorly written ransomware, so only the first couple of kilobytes were encrypted. So that means that the file systems are mostly intact. Maybe some corruption somewhere in the middle, but for the most part, you can very easily parse the entire file system. So what we can do in Dissect is we can write a custom loader, which is basically a piece of code that allows us to shape any kind of source data into something that Dissect then might understand. So what we did in this case is just scraping for file system headers, trying to open or parse a file system from that specific offset that we found the file system on, and then insert it into the file system list that Dissect can then process further. And the rest just automatically works. So we don't have to change anything about our artifact parsers. We can run the same run keys command that we ran earlier, or the same target shell command that we ran earlier, and automatically very easily browse the entire file system of this seemingly encrypted virtual disk. Of course, the command lines and everything, Dissect is built on a API first basis, and the tools that we saw earlier are really just kind of small wrappers around this very powerful API. If you're dealing with some advanced traces, you can dive into the API, write some scripts using the API, and then automate that analysis over your entire source material. Just a quick screenshot, we can see, extracting the host name, the version. This is kind of getting the same information that we got earlier on the command line, but we can also interact with the file system of, whatever machine this is. But even more, we can dive deeper into the nitty-gritty details. For example, the exact bytes that make up this file system. In this case, even dump the structure of a inode of a particular file. The most important thing to note here is that if we were to write an analysis script or a parsing script for some advanced piece of malware, if we write it using the Dissect API, it'll work automatically on any of the source material that Dissect already supports. So say you write a parser for advanced piece of malware, or a script to find some piece of persistence, it'll work on that VMware virtual disk, but it also work automatically on a Hyper-V virtual disk. And there's work on Linux systems, work on Windows systems. It doesn't really matter what your source material is now. So wrapping up, let's look at the most important takeaways of the presentation. Dissect can really be your central processing framework. If we put all of our logic, really artifact parsing into Dissect, and we just plug in new and different layers on the bottom of it. So like I just mentioned, adding a new file format for a new disk format, we don't have to change any of our logic, any of our processing, any of our automation pipelines to work with that new file format. Reusability of tools, again, reiterating, we write once and run anywhere is basically our motto here. Unfortunately, we don't have any more time left, but we actually almost had a little bit of a sneak peek on a few slides back as well about some of the things that we're actually already using Dissect for. So these are not hypothetical topics, these are actual topics that we're already using Dissect with. Such as transparent analysis on fully encrypted disks. So we have support for BitLocker and LUKS, and we don't have to wait for the full decryption of a disk. We can just go straight from a BitLocker disk into event logs and Splunk in a matter of minutes. Same with hypervisor analysis and acquisition. It was on the previous slide. We can acquire live virtual machines without having to clone them, shut them down on ESXi hypervisors and Hyper-V hypervisors.
Yeah, so actually start acquire on the hypervisor itself, and then it acquires all the guests that are on the hypervisor.
Yeah. And of course, more less typical host forensics, but things like mobile analysis and appliance analysis, router firmware, firewall firmware, stuff like that. We're also already doing that with Dissect, and the great flexibility makes it very easy to do so. Of course, it might actually help with the first CTF. It's not open yet, so we don't know quite yet, but
in 45 minutes.
Might be a good idea to try it out.
Oh, 50.
All right, thank you very much for your time. If you'd like to get involved, you can, again, check it out on GitHub. We also have a documentation page available, and if you want to reach out for comment, either find me or Willem afterwards on the conference, or send an email to dissect@foxcity.com. Thank you very much.
Thank you.
Was there time for questions, or? All right.